Hello friends, welcome to SR Physics Academy. In this video, we are going to learn about first equation of motion by algebraic method, graphical method and calculus method. In physics, equation of motions are equations that describe the behavior of a physical system in terms of its motion as a function of time. So, equation of motion of kinematics describe the basic concept of motion of an object such as position, velocity or acceleration of an object at various times. The derivation of the equation of motion is one of the most important topic in physics. So, first equation of motion is V equal to U plus AT. So in this equation, basically velocity time relation showing. The second equation of motion is S equal to ut plus half at square. This is the equation for distance time relation. And third equation of motion is v square equal to u square plus 2as. This equation for distance velocity relation. So here it is denoted S equal to displacement, U is initial velocity, V is final velocity, A is acceleration, T for time. So these are the letters we have to remember, that S means displacement, U initial velocity symbol, V final velocity symbol, A for acceleration, T for time for motion. So now you know that what are the three equations of motion. First equation of motion is V equal to U plus AT. Second equation of motion is S equal to UT plus half AT square. Third equation of motion is V square equal to U square plus 2AS. Now we derive first equation of motion. Before that, first we should know that what is distance, displacement, speed, velocity, acceleration. Here, what is distance? The actual length of the path covered by an object. And displacement is the shortest length covered by an object between its initial and final position in a particular direction. So here, the complete length of the path between any 2 points, then we can say it is the distance. But displacement is the especially direct length between any 2 points. That means here initial and final position in a particular direction. Okay, here direction is important. So that is we called as displacement. Next, speed. What is speed, or what is the difference between speed and velocity? Here, the speed is the distance travelled by a body in a given interval of time. That means the rate of change of position of an object with the time in any direction is called its speed. So we know the speed is a scalar quantity. Speed equal to distance upon time. Velocity, the rate of change of position of an object with the time in a given direction, is called its velocity. So velocity is defined as, we can say, displacement by time. It is a vector quantity. Acceleration, the rate of change of velocity of an object with the time, is called its acceleration. So here the derivation of first equation of motion by algebraic method. We know that what is acceleration? The rate of change of velocity is the acceleration. So we can write it acceleration equal to change in velocity by time taken. So we know what is change in velocity is nothing but final velocity minus initial velocity by time taken. So what is the symbol of final velocity? V minus initial velocity U by time. So this is very important. What is acceleration mathematically? We can write it A equal to V minus U by T. Final velocity minus initial velocity by time taken. Just we are going to rearranging this equation. So we see V minus U equal to what will come? This is just multiply A into T. So we will get V minus U equal to AT. How we got it? V minus U equal to AT. The rearranging this equation. What is this equation? A equal to V minus U by T. So now what is our first equation? The first equation is V equal to U plus AT. How we got it? V equal to U plus AT is nothing but this equation. V equal to minus U will come right side after the equation. So we will get V equal to U plus AT. This is our first equation of motion. How we prove it? By algebraic method. So algebraic method, you have to remember only the formula of acceleration. We know the acceleration is nothing but rate of change of velocity by time taken. So what is change in velocity? Final velocity minus initial velocity. Clear? Now this just we are putting the value here. That means the symbol V minus U by T. So rearranging this equation, we will get V minus U equal to AT. So according to our equation V equal to, we can also write it V equal to U plus AT, because this minus U it will come right side. We will get V equal to U plus AT. It's clear? Next, derivation of first equation of motion by graphical method. So we know that graphical method means first we should know the graph. One will come x-axis, one will come y-axis. So in this graph, it is what is x-axis? It is here time t, and y-axis it is showing velocity. Now, so same formula only here, acceleration equal to change in velocity by time taken. Now according to the graph in this here, acceleration symbol A equal to change in velocity means what in this according to this graph? Because see in this graph we have to calculate here the slope of the slope here. Okay, slope means is nothing but acceleration. So we have to calculate in this case what is the initial time here? Initial time is starting 0. After that what is the acceleration we have to calculate? A to B. Okay. So in this A to B, what is slope equal to? Nothing but y by x. Okay, y-axis by x-axis. So in this case, what is here y-axis? Y-axis. So because we have to calculate this slope. Okay, this slope. In this case, what is y-axis? BD. So this is BD, and what is x-axis? AD. Okay, that was red color and blue color, just to see that. So now we got it, acceleration, change in velocity. We have to calculate the slope of this here. So what is y-axis by x-axis? So nothing but BD by AD. Clear? Now, since triangle, we have to take the triangle here, BAD triangle and ABE triangle are similar. So now here the BD is parallel to AE. Okay. So BE is parallel to AE. So now and AD is parallel to OC. Okay, this parallel. Or this also DBE, but here we are taking the time t, initial and final velocity we have in y-axis, and x-axis we are considered as a time here. So in this case, instead of BD, we can also write it parallel AE. Clear? Now, and AD parallel to what is x-axis here? It is OC. Okay. Now in this graph, we know this is the from O to A, it is an initial velocity, okay, U. And what is the final velocity? O to E, that is the final velocity is V. So now we know initial velocity and final velocity. Here it is AE. What is AE here? A, okay, this one. Okay, we can also write it AE, because AE, we can also write it initial velocity, final velocity minus initial velocity. So here, what is final velocity? AE is nothing but OE minus, okay, OE minus OA. Okay, this we can also write it instead of AE, okay, AE, OE minus AE, okay, OE minus OA. Because why we are writing this on? Because we know initial value and final value. In this case, what is here? O, okay, OE is nothing but final velocity V minus, what is OA here? It is U, initial value from this distance. So V minus U by OC is nothing but our x-axis time t, because in this graph we are calculating, we know, x-axis and y-axis. That's the reason we are taking in this case initial velocity and final velocity, V minus U by T. Clear? So we can also write it same what we have done in by algebraic method, V minus U equal to A into T. Okay. Then rearranging this equation, we will get V equal to U plus AT, because minus U will come right side. So now we know that what is the first equation of motion by graphical method also, V equal to U plus AT. So here the unit, if you calculate in this case, what is V, what is the velocity of unit? Meter per second. And what is the initial velocity? Meter per second also. And acceleration, we know that meter per second square. And time taken, it is a unit is, yes, okay, second. So in this this is case, see this square and this s will cut again. See here all the units are here meter per second. Now same derivation of first equation of motion by calculus method. So we know what is acceleration, the rate of change of velocity by time taken. Okay, that means with this integration we are at a equal to dv by dt. Now it's nothing but dv equal to a into dt. Okay, just to be a into dt. This is the first equation we are considering. When it is the initial velocity is 0, then we can say that initial velocity, what is that? U. Okay. Now here this is final velocity. Well, final velocity time is also t, but here in this case here that is starting point. So that is initial velocity, and the final velocity we consider as a b. Now we are integrating this first equations within the above limitation is there. That means what the time is, we know that 0 to t time, how much time. So here the suppose I am taking here 0 and here the time is, okay, how much time it has taken here? 5 seconds total. And the velocity also, initial velocity 0 and final velocity it is 20 seconds. Just I am just general here I have taken initial velocity, final velocity, and time is 0 to time. General formula. So after that just we are integrating dv. So with dv, if you are integrating, we will get v, and from u to final velocity v, and time this a will come out, and after integrating of dt we will get t only. That time limitation is there 0 to t. Now, so after that, what we see, if you do that integration, what we will get after removal? V minus u equal to, here 0 you can, so a, what is the limit removing? So we will get t minus 0. Now v minus u equal to at So nothing but V equal to U plus AT. So now we prove what is derived of first equation of motion by, okay, this is calculus method and algebraic method by graphical method. So now it is clear for yours. Three types of methods here we used to derive first equations of motion. Hope you understood. If you enjoyed this class, please subscribe our channel for more videos. Thanks for watching.